Okay, my name is Mike Martin, and coming to talk to you today about the MSH uBRAIN and installing it on a 180 CFX, a Blade 180 CFX, and going over the basic setup process with it, and how to ensure that you're going to have a good, successful maiden on the first try without any issues. Okay. Now I gotta resituate everything a little bit so you can see better with the GoPro. I have taken the head off of my 180 to make setting up for the first part easier, and I'll show you why here in just a minute. But here's the 180, and what I'm gonna plug it in real quick. Right now I have the batteries completely disconnected. I got the motor leads unhooked for safety. The DSMX satellite is completely unplugged. I have defaulted back to factory defaults, and I'm going to do it a second time here just to show that it's done for the video purposes. But say you want to hook this thing up and start programming it. You got all your servos plugged in and what have you, and you go to do that. This is what's going to happen. And if you see how everything's kind of jumping around, it's because there's just enough power going to it to function it, but not enough current not enough available current for it to react and work properly. So what I strongly urge you to do is, instead of going about how I just did that, like treat that as a kind of a big no-no. Instead, take your battery, plug it in first with your your motor leads unhooked. Plug it in. Now, hook this one up to the laptop. And then go online here. Pops up COM port 5. Say OK. Select uBRAIN because that's what we're on. Tell it OK. Now, this is the advanced menus. What we want to do is make this full screen. Come over here. Select Basic Wizard for setup. Now then, I'm going to default it again one more time. Reset to factory defaults. Are you sure you want to reset the unit? Again, OK. Press OK. Close the configuration. Power off the unit. Now, I'm going to go back in. It is 100% certain that it is no longer got anything in it. So I'm going to power it back up. Now then, look at everything, make certain. Ooh, there's a problem. So we saw it starting to kind of bind up on the tail servo. So I'm going to pop this ball link off. That is just to ensure that there is no binding. Now I'm going to go back in, plug it back in. There we go. Nothing's bound up. Plug in our USB port, COM port. We're going to go online with it. Right here, typically, if there was any firmware versions that we needed to download to the system, it would let us know right here. And if we were on the internet, or if you're on the internet or what have you, you got to be on the internet. But if there's available updates, this will tell you right now. And you tell it yes to go ahead and update, no not to, whatever. I would strongly recommend taking advantage of every update Corrado puts out. MSH puts a lot of work into these updates, and it's only to help the user to be more successful and have a better flying, better performing machine. Their goal is to be the best on the market, and they are doing everything in their power to make that happen. And they're doing awesome at it too, in my opinion. But so now we select micro brain again. Tell it OK. Now we're back here again, but now we're at 50 hertz and 50 hertz, whereas earlier I had it set, well, no, you didn't see it then. Originally it should be 333. So that tells me that we're defaulted. Nothing is selected here. So that's another sign that we're completely defaulted to factory settings. 50 and 40 here. So there we go. So now we're going to come back over here. The reason why it gives you the option on the servos first here, whereas on the big one it gives you the option to set the radio up first, that is because some of these servos that are in the smaller micros, they work on a lesser frequency and pulse width the center pulse and what have you. So it's to keep you from burning your servos up. You set that first, and it's set at the lowest possible settings to start with, to ensure that you will not burn them up. So these will work on 333 hertz. So come over here, you can select 200, and over here the tail is 1520 and 333. See, this one here says 760 and 333 and 760 and 560. We want the 1520, and then we will raise the hertz to 333. So there's 1520. That puts us at our, if you notice too, the servo that was all the way back at home position centered up right away where it should be. So now we can take the slider and raise it on up to 333. And that will get our servos to operating at their most optimized settings possible. Now, when I go to the next screen, that's when it's going to update and tell these servos, that's it, 333, operating frequency, 1520 center pulse width. So, now then, here's where you select whether you're on the DSMX, DSM2, or whether you're one of the other operating protocols. I fly JR11X, and everything that I fly is DSMX. So what I will do now is select DSMX, and then if you need to keep in mind as well as you're going through these steps, I kind of didn't say this in the beginning, I should have. You need to read from top to bottom. This is just like reading a book. Left to right, top to bottom. Start top, do the first one on the furthest to the left, and then keep progressing to each step. Tab 1, tab 2, tab 3, tab 4, and so on till you're done. Read through these, make sure you fully understand them. I'm going to do the best I can throughout this entire process, but there are things I'm confident I will forget or not even think of, maybe because you might be on a different protocol and there might be things that I just haven't experienced personally. Because, like, for example, I've never flown the M-Link or the S-Bus 2 or the S-Bus or the PPM. I've just never done it, or the Hotlink. So just keep that in mind. I'm doing the best I can, but at the same time, make sure you read and understand these, and jump on HeliFreak or Run Rider and blow them up with questions if you don't understand it. So anyways, now we're here. I want to bind it to my radio. So what do? I can't really access it so easily anymore. There is a way to bind it with using a pinout and jumpering it similar to the big ones with a bind plug. But the way that Corrado and Rick have done this now, it is super easy. All you do is come down here, check this bind box, and it prompts you. Turn off the transmitter, cycle power to the unit, turn on the transmitter with the bind switch pushed. And it doesn't get any easier than that. So, well, that's what we're gonna do. We're gonna tell this thing okay. So we're gonna unplug it so that it completely kills power. Cycle power to the unit. We're going to plug in the satellite. This time when I power it back up, it should start blinking like crazy, letting you know it's in bind mode. So here we go. Plug it in. And if you notice, it's blinking, like I said, super fast. That's letting me know that we're ready to bind. So what I'm going to do, set it down. I'm going to take my transmitter that's now off. Make sure everything's in my default position. Normal mode, throttle hold off, all that good stuff down. I'm going to depress my bind button here on the back. Turn on. Now then, it's going through the bind. The light went off on the satellite. And there it come on. Now it's bound. So I'm going to let off. The swash just jumped, let me know that it is bound completely. So, now that we have that done, now we can plug ourselves back in here. Let me show you real quick. See there, it's solid, so it lets you know we're bound. Plug back in. It just prompted me to let me know that it sees the system again. Now we're going to go back through, make sure we're still at 333 and 1520. DSMX. Now this tells you how to set everything up. Now, there's two different pages that's going to show you this, but with the helicopter facing similar to what I have it right now, with the nose away, tail towards you, the swash is, I hope you can see this. The swash that we are using is 120 degree CCPM swash. That's either going to be this one or this one. This one here is for the old school style Raptors and such. We don't use that. Maybe like some of the fixed pitch blades do. If you wanted to put one of these on one of those, that would be where you'd use it. But anyways, this is the one we're using, where the elevator servo is in the back, or where the control arm comes to the swash is in the back. If the elevator was in the front, then we would use this top one. But what that's telling me is that whatever, so now we know it's this one, whatever servo goes to when you're tail in to the right side servo ball, that is where servo number 1 is going to be. That is what's going to be called servo number 1, and it plugs in to servo SRV1. Now servo number 2 is going to be your elevator, and that one is going to, you got to look at to whatever controls that back servo ball right here, which servo hooks to that, and follow that wire out, and that servo is going to hook to SRV number 2. And then the same with your left side servo ball. That the servo that goes to the left side front is going to go to servo number 3. The tail is always going to be servo number 4 with the brain. Okay? This tells you as well where everything else is going to hook up to, should you not already be aware of it. The system I/O port, it's kind of I don't want to say foolproof, but it's pretty much the only one with 4 pins, and you just got to make sure to put it in right. And if you're trying to force it and it's not going, you probably got it backwards. So that way you can kind of see how to hook everything up. The ESC just plugs straight into the throttle, and then everything's good to go from there. Now on to the next one. Now this is where things get critical, and a lot of folks want, I don't know why, but a lot of people want to interpret this their own way or what have you, and then they get mad saying the brain is goofed up, and it's not the case at all. So in 1 second, and we're going to start this one. I want to take a good amount of time and explain it. Okay, I just took a minute to reposition everything so that I could explain this and as best as I can detail wise, because there's a lot of questions on the forums that this step right here could easily take care of the problems that are being presented or that the folks are seeing or what have you, if they just understood it a little better. So I'm going to try my best to explain this step as thoroughly as I can. What we're looking for here is when you go into your radio, whether it's a JR, a Spectrum, or whatever, you're going to go into your endpoints, and my list, I'm going to go to travel adjust. It's the same as my endpoints, and here I got throttle, aileron, elevator, rudder. You can see they're already different values, and then the stock over here, the 100, negative 100, that's how it comes. These are, I've already had this helicopter, like I said, set up. So what you're looking for is 100% on here. When you give a right aileron command, you want to see the center slider go to the right, and you want to see the value say 100%. When you give a left aileron command, you want to see the slider go to the left, and you want to see it give a negative 100% aileron command at full stick deflection. The same with the elevator, nose down, nose up, tail left, tail right, pitch, positive, negative. The gain is a little different, and I'm going to show you that here in just a second. So let me start going, and so we're on aileron right now, and I'm going to give an aileron right command. Now then, the slider went all the way right, and I hit 101%. Another thing you can tell if you're good or not is when you go all the way over, see how it turns green? If it was, let me go too high and I'll show you how it does. So aileron right, I'm at 101, I'm push the button. Now I'm going to be raising the aileron command. 102, 103. Now then it just changed. It's no longer green. Now it's back to gray or what have you. Just like it was when it was in the 90s. That tells me right there that I am too far out of the range. And it will get, that means your commands are going to be out of calibration. One thing to keep in mind though, with the Spectrum radios, the DX8, DX9, DX7, the newer ones, you have to get your commands, like they may be backwards at first. Say you go right and it goes left, you need to get the endpoint dialed to the 100% first, both directions, right and left. And then if the slider is physically moving in the wrong direction, you'll go and reverse it in your radio at that point. That's only for the Spectrum. For the rest of them, you can reverse it first and then set your endpoint or whatever you're more comfortable with. But for whatever reason, the Spectrum radios has to be that exact process or it will not function properly. There's something to do with the software, and I'm not exactly sure why it is, but that's just the way it is. But anyway, so now say I went to give a right command, I got it 100%, but it's showing the slider going left. At that point, I would come into my radio here and go back to my reverse switch channels, and I would reverse my aileron to make sure to get it to going in the right direction as far as what the brain is seeing here to what I'm telling it here. This on this page, this is the only spot you need to reverse any channels, period. End of story. This is where I see a lot of people get goofed up, and later on they try to flip to auto level and their helicopter gets driven into the ground with the force and major vengeance from hell. This is why. They get it set up here, they get down the road setting up the servos for whatever reason, or see something not working what they think it should work, and they reverse the channel here. That is what causes problems. You can't do that. You got to do what the setup process tells you in order to get your helicopter to function properly. So please just take your time, read the directions, and do like it tells you. Now, so I'm going to go back and check my left and right. We're at 100 left, 101 right, nose down. We're going down like it says at 100%, nose up 100%, actually 102, but we're still good, so I'm going to leave it. That one's actually 101, so it's still good. I'm going to leave it there. We're going to pitch. Now my pitch, let me go to idle up one, that way positive 100%, negative 100%, center is about 0. Actually, if I centered it, we would be dead on 0. There's 0. Now, rudder, nose right, 100%, nose left, 100%. Now, put back down. Your gain on most of the brains, you want to set it to 45, right? On the CX, the 180 CFX, you want to set it starting out at 20 is what they're recommending. I personally would recommend you could try it at 20. If you see the tail start to jumping back and forth, it depends on your head speed at this point. 20 with the default normal head speed value would probably be really good. But if you're running stunt 2 or whatever, the idle up 2 at 50, 200 RPMs to 6,000, anywhere in that range, you're going to need to lower your head gain or your tail gain. Like I'm running mine, default says 20, I'm at 13. Sounds low, but it's not. This tail is like rock solid. I'll be happy to share some videos along with this of cranking out hurricanes as fast as this thing can fly, and the tail doesn't act nervous, doesn't chirp, doesn't twitch, doesn't float. It's just there. So I mean that, and I'm in North Texas, and we typically have on this time of year 20 to 30 mile an hour winds, and I'm flying this thing out here in the yard with 25 mile an hour winds on a micro machine of all things, and it's just taking it like a rock star. So I mean the brain, that if that's not gonna sell it, I don't know what will. It is unreal how good this thing does in the wind. The tail is like a 450, my 700s. It's great, consistent. I can pyro flip this thing all day. I can do. I'm not the greatest at pyro TikToks, and I mean at times I nail them pretty good with the 700. But I mean I've nailed them with this thing, and that's unheard of. I cannot believe I can do pyro TikToks with the 180 size machine. That's unreal. Okay, anyways, off the sales pitch. Say, for me personally, my bank switch, that's this right here where it says current setup, and it says setup 3. If you come over here and read, it's going to be your either default is going to be channel 6 or 7, depending on what you assign it to. I assigned mine, I believe it's 7, and it's yes, there we go. I was right the first time. It's the flap channel for me. I like to fly with it forward as all the way flipped up as bailout, setup 3. This one I do backwards. Then, like, normally this is my setup 1 on my big ones. Well, this one here, especially for using bailout so much, trying to learn it, figure out the bugs and help out, I've got it backwards. So all I got to do is if I'm flying normal, and if I get to where I want to try, it's boop, like that, and I'm bailed out. That's my personal preference. You don't have to do it that way. If you want it the other way, simply just go in and reverse the channel. Okay, that's me personally. So there's that. Now this one here, if it's red, I got set to a value of 20. That's heading hold mode. There's a method for setting the tail up and heading hold that is very, very beneficial, but I'll try to go over that at another time. I have a video on my channel about that. I'll try to link it to this as well. The middle, if you set it to the middle, that basically turns the tail gyro completely off. Heading hold, that's where everybody flies. So green, the box is checked. Heading hold, I'm down at 13% because I fly a higher head speed. I think mine's at like 5,800 RPMs, something like that. Now you can control that inside the Castle software. Now this is all done. You got everything traveling the right direction. Your throttle's minimum at bottom, max at top. Pitch is going the right direction. Your tail, your elevator, everything's going the right direction and reaching 100%. That your radio is calibrated. You do not ever go back in and adjust anything again in this setup section except for your tail gain, and that's if you choose to leave it in your radio. There'll be a step later where you can set it in the software, but if you got 7 channels or more on your radio, I strongly recommend leaving that in your radio, just because it's easier for tuning it later at the field. So now we come here. This is where we're going to tell it what we are. With the tail in, the elevator, like I discussed earlier, the elevator servo is in the back. So that's what it's defaulted to, because the guys at MSH feel like most people are going to be buying these for this helicopter. So that's what they defaulted it to. I don't know what an Oxy 2 or Oxy 3 is like, or any of the others, but so you might have to pick 120 or 140 with the elevator servo in the front. If you do, then just whichever one matches your setup, that's what you choose. 140 is typically a JR setup. I think the Raptors, they might have it as well. But anyways, here's the next step that people get a lot of. They bring up a lot of stuff, and right here is where folks get goofed up, and they want to blame the system, and it's not the system's fault, unfortunately. I mean, I'm not trying to say anything negative, so please don't take it that way if you're one of those folks, and I don't intend to hurt anybody's feelings with this, but this right here is so critical for the auto level. There's ways you can make it work without this being right, and it still fly pretty good. And then one day you try to auto level, and like I said earlier, it'll drive your helicopter right in the ground. that's all for not doing this part right. So what they're asking for here, if you take time to read this, it'll describe in great detail, but what you want is for your servos, the arms to be at 90 degrees with the servo. So it doesn't matter where this swash is at right now, as long as you get the servo arm at 90 degrees with, let me move this, I'm gonna pause it, hold on, I'm gonna pause it. Okay, I kind of moved everything around just to help simplify things. What we want here is these servo arms to be at 90 degrees, and to also, when you hit this plus button, the servo needs to move up. When you're at center stick at zero, what they want zero pitch to be at 50, you know, you're not in, you're not out, you're zero. They've also made the dead band incredibly huge here, so either you're at zero pitch or center stick, or you're at max, or or you're well. Let me rephrase that. I'm moving it right there, and I'm still at zero pitch. That's so that you can find center easily. Now then, 100, it goes all the way to get 100, all the way down to get all negative. Right there is all we care about in this step. That and making sure these. Now, right now, a lot of folks are going to say, "Oh, well, your swash is moving in the right direction. You're all good." That couldn't be further from the truth. Yeah, it could fly right there, but it's not going to correct properly come time whenever you need to auto level, or even for that matter, when we're done setting up. If I went through the setup right now and went to the end and it said to look if make sure my sensor correction is proper, the swash is going to do all kinds of goofy movements as compared to what it should do. It should try to stay level as you move the helicopter. Without verifying that these servos are traveling in the right direction, it will not. This is where also a lot of people like to try to go back in and reverse channel directions, and that is terribly, terribly wrong. That gets more people in trouble with not only this system but every system. So please just verify that these are correct. Now I am at 50% should be zero pitch, or yeah, center. Now if I look, this one here, like I said earlier, this is number 1, number 2, number 3. Number 1 is very close. If any, it might need to bump up just a hair. But what we're going to do now is I'm going to hit this button a whole bunch of times. The only reason why I'm doing it is because this is a micro and it takes so much to move it enough to where I can physically see it with my hand, with my eyes. So I'm going to put my finger here also so I can feel which way the horn is going, and I'm going to start pushing it. Now I'm telling it to go up. I don't know if you can see it or not, but it's actually going down. It's pushing my finger down. So I'm going to hit reverse. That number just changed to -45. Now I'm going to have to go up again. I'm going to go back to 0. And I'm going to leave it there. I'm going to go to servo 2, which is the elevator. And once again, I'm going to try to find a way to rest my finger in a manner so that I can feel it move. And I'm going to go tell it to go up. And okay, now it too is going down. Now here's where it gets tricky. If I hit servo reverse, it may or may not fix this direction. This is where also people get goofed up. What it's actually doing is there is a combination of what these 3 servos can be. I believe it's like 9 different possibilities. Every time you hit servo reverse, it doesn't reverse the one servo, it reverses the combination. And so you have to keep going and checking all 3 of these until you get all 3 of these moving in the right direction. And that tells you that you're on the proper combination. Okay? It takes, I know that sounds confusing, it's very difficult too to explain on a forum and typing. So that's where these videos come to play. So I'm going to hit servo reverse again on this one. And now start hitting the button. And now I can feel it moving up. Go back to 0. Now then, I might come back and double check this one now. Let's see how it does. Hit up. Up, it's going down again. This is where people start really getting goofed up and they're scratching their heads thinking they got a broke machine, broke system. It's not. It's just the combination it went to next told this one to go down again, this one to go up, and it might have reversed this one as well. So we know it's wrong, so we'll just go back, you know, hit this again. Now we're going to tell it to go up. And it's moving up. So we're going to take it back to 0 for now. Now then we're going to tell this one to go up. Number 2 again. And this time it's actually going up. So now we got 2 of them correct. Now we'll put it back at 0. Feel it come down. Okay, now we're going to go to number 3. I'm going to turn it around. I want to feel it go up whenever I push the button. Get my hand away where I can feel it. And what do you know, it's going down. So we're going to tell it to reverse again. So now then, tell it to go up. Okay, so now we know that number 3 is right. Let's go back and check number 1, which is over here on the other side. And it's going down again. Now it's going up. So now we'll go back to 2, check it again. And it's going down again. So now I tell it to go. Okay, now we know it's going. So we'll go back to 0. Then we'll go to 3. Okay, it's going up. It's going down. Now then 2. It's going up. Going down. Now back to 1. And it's going down when it should go up. So we're going to go and click on it one more time. See what it does. Now it's going up when it should. Going down when it should. Number 2. It's going down. I'll put it back up. This one should be the one that makes it all good, if I remember right. Now this one's going to go up. Yep, now it's moving up. Okay. So now that we know it's traveling the direction that the brain is telling it to travel. Now we want to level it. This is where I use a method on this helicopter. Okay, now then, what in order to get, once I got all of these going the right direction, first you get to where you're down eye level or what have you whenever your stick is at center. So you should be at 0 pitch with the swash level, right? I ended up, in order to get what visually appears to be all of the arms at 90 degrees of each other, one of these had to go to -7. That's only being because the way these servo arms are made, you can get it right with little to no offset or what have you. Now, this is the part where people also get, I don't want to say confused but I don't think they understand everything fully. And I'm not saying that anything negative towards anybody, but so if you're one of those people, again, please don't take it personally. I'm not intending it to sound or be that way. But what they want here for optimized geometry and for your helicopter to fly at its optimized abilities, or utmost the best that it can fly, these servo arms have to be centered at 0 stick. At center stick, these arms have to be 90 degrees of the servo. Then the swash has to be level when they're at 90 degrees, not whenever they're tweaked or trimmed. So you see I got one here that's -7. That's because it's just really difficult to get to, and the easiest for me to center it was to bump it till I got it to where it's -7. These other two you can easily get to them and adjust the servo arm with the way that these nano servos are, what have you. Now, to get this swash leveled, what you want to do is take, like this is my method. You can buy a swash leveling tool, which is the absolute best way, but being a micro, I'm trying to do this and show the most budget minded methods possible. So I took a zip tie like this, and I cut the end off like this. I'll show another example. So now the zip tie is missing the bottom. That way I can get it as close to the swash as I can, and it still latches and holds. See, it still holds. It's just missing one side. So now I can get it all the way down. Put it on here, pull it up snug, cut it to the length so that it makes all 3 servo balls as you go around, and then rotate it by the main gear. Check it, see what the gap looks like, then go to the next one, check it, see what the gap looks like. They all 3 need to be the same, or so close you can't tell the difference. That's what we're looking for. If it's off, you do not use these buttons to adjust this. What you do is you pop the ball link off, like this one here, need to come up just a hair. And I made it off on purpose. That way I'd have one to show an example of. So I unscrew it a half turn. Now I'll put it back on and go around again, check all 3. Get it to where it just barely doesn't touch. Like that. Now let's go and see if it looks the same over here on servo number 1. And it's off a hair. Servo 1 might need to come up a hair. Servo 3 is identical now. Yeah, that one's got to come up just a hair. So those two need to go up both just a hair now. So I'm going to go another half turn. And keep doing this process until you get them all to being the same, all the way around. That is to get the most optimized geometry possible. Without having the geometry optimized, you're fighting the system already. You know, these helicopters have come so far. It's unreal how much the technology has improved upon in the past couple years. To not take advantage of it by the best possible mechanics is just asking for problems. So just take the time and do it right, and you'll be thanking yourself later. So there's that one's just barely touching. This one's just barely touching. And that one's just barely touching. So there we go. Now we're at a level swash. So now if anything needs to be adjusted when I put this head on, right here, you know, the lengths are solid. There's no adjustment in these. So when I put it on, if it needs to be adjusted any, it's all in adjusting it by these three balls, by unscrewing them or screwing them in order to hit that zero pitch. And there's a trick to that, and I'll show it to you in 1 second. Okay, now back. I'm going to show you the way that we got the swash is set to being level, and the servo arms are centered at 90 degrees. Now we're going to put the head back on and check for zero pitch without a pitch gauge. This is a trick that a good buddy of mine taught me. Bobby Jack's Hobby Shop, one of the guys that helps him, guy taught me how to set up pretty much most all of what I know now today as far as setup and ensuring that my equipment is set up as optimally as possible. So first what we're going to do is put the head and the blades and everything back on. That's what we're going to do now. So I might have to move it for a minute so I can get this screw in, guys. So bear with me 1 second. So now that the screw's going, got that back in, snug it up. Take pop the ball links back on. Okay, so now, as you can see, we have our head back on. where pitch is still the default 40 and the cyclic is at the default value of 50. I'm gonna slide this back some so I can move this little guy back and give y'all a better view of what is going on. So now what I'm gonna do is, I believe that to be 0 degrees. And what I'm gonna do is, we know that the arms are 90 degrees. We know our swash is sitting level now. We know that these two arms are the same length. There's nothing that can be adjusted with those. We got the bolts are all in the head, the bolts are all in the main gear, so nothing can move up and down. There's no vertical slop anywhere. You know, outside of it's plastic, what it's going to give anyways. So what you can do now is you can take these two blades and fold them straight back to each other and get them where the tips are close to each other. If this one should hang a hair lower than this one, and that would be 0, and that's only because of the play and the head and the way that everything works. This one's sitting on solid posts or what have you, where this one's hanging and it's got all the slot pulled up. I hope that makes some sense. So now what you can also do now to double ensure that you're fairly close to level is rotate it and keep an eye as to what the two blades do, because they shouldn't be moving. They should stay about the same. And if they move any, and say they alternate, and at one point during this rotation, the one that's lower then becomes higher and vice versa, then you know that your swash is out of level and sitting on an angle to where whatever side it goes up on, that's the high side. And you have to go back and redo your swash setup. So they're staying very, very consistent all the way around. I'm gonna wait and call that 0, and we're gonna see how that does. Alright, now I know that also another thing with the pitch, you can take, and it's a really long drawn out one, so I'm going to send a link. I'm going to try to post a link in the notes or what have you on the video. But basically what you do is for finding your pitch and your cyclic is a 0 with the pitch at 0. You can rotate your cyclic to the max, and you can fold them back this direction, say, and measure basically from here to, move it to where I can show you, from where the skids are sitting to one of the tips, and go to the like that to where it kicks it down to the furthest most. And you get your measurement again, you subtract the two, and then you figure a mathematical, there's an equation that goes from measuring the bolt, center of the bolt, to out here, and that gets you comes up with a degree difference from there to there. It's also the same with pitch. That way and that way, you call this 0, measure tip to tip, divide by 2, and then you figure the distance from the center of the eyelet to the outer, and it gives you a mathematical equation as well. It took me a good bit of, and because honestly I'm like 37 years old now, and I haven't been in high school for a good 20 years, so it took me a bit to figure it out and to remember again, even after reading the Google how to. But that's how I went about figuring my pitches, and to make sure I'm within You want to stay within 10 degrees on your cyclic and no more than 10 degrees. You want to stay more than 8. So it's a pretty good window. You want to stay between 8 and 10. Any more than 10 and you're liable to get some weird interactions with the head. Sometimes some people can run higher and they get lucky and things work out great for them. Sometimes you go to 10.5 and because of your mechanics or what have you, it's just enough to get you out of whack. Me personally, I honestly couldn't tell you what I have for the pitch. I go out and I flew it and I punched it and I listened to the motor to see how it bogged or not, and depending on how it bogged and how it felt to me personally with knowing my liking, I raised up the pitch a little more, tried it again. I kept doing that until I got it to where I liked it. And I did the same thing with the negative side, just positive, negative, turn it upside down, punch it straight out. So that's another thing as well with doing it this basically the poor man's way, or I don't know. That's a poor choice of words, but if you go outside and you're sitting there and you go to pop it up into a hover and you've got it stationary and it's sitting pretty good in one spot and you just give it full collective to do it as a straight punch out, and say that when you're punching out the helicopter goes this way as it's climbing up, and if you punch to negative and it goes back down that same orientation, that honestly would tell me that I need to give it a little more on the swash, that maybe I'm off just a hair with my with my zip tie. So I would extend the ball link a hair on this side, or I would screw these in a half a turn, one, you know what I'm saying, to get it this one, or vice versa. If I'm nose down punching straight without giving any elevators input, that would tell me the same thing as well. Once you get, I don't want to get you too off track, but that's some kind of little tips and tricks on how to verify that your swash is set up right without a swash leveling tool. And granted that you can't beat a swash leveling tool, it's worth every penny, but some people and maybe you don't mind spending the money, but you don't want to wait on the mailman. I'm with you there too. That's a method of getting around it as well. So now that we got that to where we're pretty confident that we're going to be golden, I know with the cyclic at 48, when I did the math on it, I come out to right at 10 degrees after figuring my dimensions. The pitch, like I said, I can't tell you where it's at. It works a little different than the cyclic. I want to say just from feel, I'm guessing I'm between 12 and 13, but I could be way off. But anyways, now we're going to go on to the tail. I'm going to stop for just a moment, replace the battery, and I'll see you in just a minute. Okay, now we're going back to we're going to be going over the tail now that we got the head and everything to where we're close enough for a maiden. So what we're going to do now is go on to the next step, and it pretty much tells you everything we need to do right here. So we're going to basically, what you want to do with the helicopter setting, similar. Let's see here. I'm going to kind of set it on the computer. So that it can be seen. And we're going to turn it some. Now, earlier we had to take the ball link off when we were first setting up the servos to the operating frequency. So now I'm going to put the ball link back on. See, right now it's off so that it doesn't bind up anyway. If we go moving the the end from end to end, it moves properly. Well, we don't know that it moves properly, but we know it moves, and it goes back to center like it should. So yeah, I'm fighting this just a wee bit. Now, got the ball on. Move that to where hopefully the camera's picking it up. Now we're going to tell it nose right, nose right. So if we were rotating clockwise, that would be blowing air this way, which would be ultimately cutting and screwing the tail that way, or driving it to that direction, which means that would be nose left when we're really being told to go nose right. Or we want, I'm sorry, when we want to go nose right. Is it nose right? We're going to go left if we left it the way it is. There's the other direction, nose left, and we're going to really go right. That's how we want it to be the other way. So some people will go in here and they will reverse their tail servo in their radio, which couldn't be more incorrect. You want to hit this button here, it says servo reverse, and it talks about how to do it right here. So you just one time. Now you tell it to go nose right. If you look, it's going to be driving and biting into the air and blowing air that direction, or the right direction, and screwing the tail to the left, which means that the nose is going to go right that way. Same with this way. See, we're nose left. If it's spinning this way, air is going to be blowing to the left, driving the tail to the right. Air left means nose left. Air right means nose right. I mean, kind of think of it that way. You gotta imagine if it's spinning, which way it's going to be blowing the actual air that it's cutting through. And that'll help you to determine what direction it's going if you're not sure. Now, what we want when we go to, I'm going to move this some. I hope you can see the arrow on the screen still. If not, forgive me. Doing the best I can. But we want to where this tail pitch slider, we want it to go all the way to where it doesn't have any more travel without binding both directions. And as you can see, hopefully you can see, we still have a good, I don't know, 1/16 to 1/8 of an inch that on the nose right direction, and we have about the same on the nose left. So what you do is you give it a nose right command now, and then you come over here with your, and you push this plus button, and you keep, and if you watch, every time you click it, it's going to move a little bit further. You keep clicking that button until it gets to a point where you can hear this ever so slight binding sound to begin, and then you back it off one click, and then you call it good. Then you're going to do the opposite, the same thing with the opposite direction, all the way till you hear a slight binding sound, and then back it off one click, call it good. That way you're just before reaching mechanical limits, getting the absolute maximum potential throw out of your tail. That's going to be the wider, the bigger, or I'm trying to think of the best way. The more you can get out of that, the better off your mechanical abilities are going to be with your tail optimization. So okay, here we go, nose right. We got about a 1/16, so we're going to start clicking, and it's moving. Hopefully you can see it now. We're about to bind. 1, 2. There, it just started a slight bind sound. There's a lot. So now I'm going to back off. 1, 2. I hope that the camera or the microphone picked that up for what I was trying to achieve there. Now we're going to do the same thing the other way. Keep hitting that till it maxes out. Now back off 2 clicks. That way, there, went 3. Now on this one here, I did actually have to give a little pitch pre-comp. This is the first helicopter that I've set up with the uBRAIN that I was actually had to give some tail pitch and cyclic pre-comp to help hold the tail, and I think it's just something to do with it being a micro. I'm not sure. All the like the big ones, the Max, the Protos Max, the Mini Protos, the T-Rex 450L, 600N, 700N, 700L Dominator, the Chase 360, the Galley X5, Galley X7, all those that I've helped set up or set up and owned personally, I've literally never had to give any pre-comp once I set everything up properly or what have you until this little helicopter. So maybe with it's, I don't know what the reasoning behind that is, but that's just the way it fell in for me. So I'm going to hit clockwise because that's the direction that the rotor's spinning, and that way whenever I go to add the pre-comp from and then just click it and click it, now it's going to add some default based on the gain and everything that's already set. Now, say I had a DX6 or 6i, one of those with it's only 6 channel, and I'm trying to free up a switch for bank switching so I could use the bailout function. I would click this set in software button here and set my heading lock permanently in the software. That way I wouldn't be tying up a channel from my transmitter to accommodate that. But seeing how I got an 11 channel JR11X, I'm not going to be clicking that button today. So now we got the tail done. We're going to come here. This one's another very critical a very critical setting or whatever. The uBRAIN, I don't know if you can see it, but the way I have it in here right now, it is facing up with the wire plugs in the front. So what we want to do is move sideways so you can see. We're going to tell it top up, wires front. Click that. Also, while we're here, we're going to hit set level. What that does is it tells it that it defines where level is for the auto level accelerometers, and you know we will have to tweak it in some when we go to setting it up on the mating for the first time, but it will be very close here. It might drift one way or the other depending on work, because my dinner table is probably not actually perfectly level. So when we go to set it, when we go to fly it the first time, we're going to have to tweak it a hair one way or the other. So that, and another thing too, when you move out of this step and you come back, you'll never see that highlighted again, and that used to kind of confuse me when I first started setting my brains up back a few years ago. Why set level never stayed highlighted even though I didn't move it. Well, even though you didn't move it, you know, just the little bit of your table moving around or what have you, you're not going to get it back to that same perfect dead nut level or spot that it's determined to be level after you push that button. So that's the reason why you'll never see it highlighted again once you move beyond this screen. But once you click it and it's highlighted like it is right now, that's it's it. You're good. You're done. So now we'll go to this one, and we're going to identify it as the 180. That's pretty much it. 180, 250, 300, 450. Well, we're 180, so we'll call it done. So now, come over here, we want to tell it that we are going to be flying, and either, my personal preference is hardcore 3D. It doesn't mean that you're Burt camera or anything like that. It makes it so that the roll rate is set to where it rolls X amount of degrees a little bit faster for X, the Y, and the Z axis as compared to the 3D, as compared to the sport or the beginner. I think these two roll at like 200 degrees a second or something. 3D rolls at like I want to say like 300 degrees a second. The hardcore, I want to say it rolls at like 480 a second. And even there, I'll typically go in and I will personally adjust those more. Like I'll set my tail roll to 540 degrees, and I might bump my aileron and elevator roll up to 440 or so. You know, just a little higher than where it is. That's just my personal preference. You don't have to do that, but that's how I like to do it. So anyways, now that we're here, and say if a person, I'm going to set one at 3D and the others at hardcore. We're going to do the throttle calibration. As you can hear right there, it beeped off, but it never armed. So in order to calibrate the throttle, we're going to go back in here. And this time, however, we're going to go into the full size software for the standard brain. We skip everything, go straight to oops, wrong one. Okay, now then, like I said the first time, we'll go to the full size brain. Hit OK. Now we go to the channel for the governor and whatnot. And basically this up here just populated with the default value. We're going to go right here and we're going to, there we go, 1073, 1960, and we are now armed, and at 1960 we will get 2 milliseconds, which is equal to 100% throttle in a castle speed control. So now that we're good with that, we're going to go and exit out. Disconnect everything. Now, if I give any throttle command at all, it should start spooling up in the proper direction. And there it goes. And we're correcting the right way. Everything's good. So now we're ready for a maiden. I'm going to make some videos showing you the maiden here in the next couple of days, if weather permitting. So hopefully it won't be too much longer, and I will get some videos as well with the maiden and dialing it in and tweaking it and showing how to tune the auto level as well as the governor. I would honestly though start with the governor on the default settings, because what blades defaults are set to are very good with this machine. Anyways, if you have any questions or comments or suggestions, please give me a holler. Let me know either here on my channel or on Heli Freak or Run Rider or Facebook. It doesn't matter to me. Appreciate your time, and if you enjoyed watching it, want to see more, please subscribe to my channel. And I'll be posting videos up regularly of fun flies that I attend, as well as videos of myself flying and tutorials as I can get the opportunities to make them. Also, if you're ever in my area, stop in Bobby Jack's Hobby Shop. He's a good guy. He supports the hobby, and he supports me a lot and helps me out with keeping me in the air, keeping all the folks in the air in this area. And also, as well as MSH. Without MSH, there's no way I'd be where I'm at today. I got to thank those guys: Corrado, Alex, Rick, Simone, Thomas, all of them guys. Man, they're some of the best guys out there. So anyways, show your support to the ones that support the hobby, please. Thank you very much.